So I made, hang on, drop the microphone a few times. So I made a couple of changes to this week's assignment and content. So please be aware that there is a quiz that will pop up hopefully today, depending on how quickly I can get out of some meetings. So there is an assignment, there is a discussion board, and there is a quiz this week. This is the last week we're going to use the PDF that was provided to you. From now on, you will need that Python book, which is, not that you guys can see it, the rest of you, but it is this absolute beginner's guide to Python. So if you haven't bought it, get your butts in gear now, because you will need it, and you will need it quickly. It is cheap. It is like 20 bucks or less. If you buy it on Amazon, it's probably like 10 bucks. It is an old copy of a textbook, but it's going to work for our needs in this particular class. That said, if you don't have it this week, can I pass this class? Yeah. Python, one of the great things about Python is there is tons of content out there. We're going to show you again python.org and some of the items that are in there. So you may find that you want to go to those. It's a great resource, and it's a great way we can get information and utilize it. The textbook really just gives us an additional framework that we're going to use. So this week, we are going to cover all of these pieces, hopefully, so you will be able to answer this particular assignment after watching the videos or being in class. We are going to talk about the last segment. So you're going to see some content we're going to look at out of the book, and we talk about the idea of classes and inheritance and objects. So Python is what we call an object-oriented programming language. So we need to know a little bit about what an object is so we can move forward a little quicker. All right. So the first thing I want to do to kind of break everybody up, most of you, especially those of you in class here, already have Python. But I want to go to their website again. So this should be a site you have memorized at this point. So I'm going to go to python.org. This website is the authoritative guide. If I want to understand anything about Python, this is the place to go. It is not the only place, and you'll see that we set up some other resources that hopefully you'll be able to use. But this is the authoritative guide. These are the people that publish the code that we are going to use. So if I simply want to download and install, notice I can quickly say I want to download for Windows, and it's version 3.7.2. Couple of things. If you have Windows XP, you're going to have to find an older version. If I have another form of platform I want to use, so Macs, for example, Macs have several different versions, and it doesn't have just a quick download here, grab the latest version for me. There is a split in Python. So somewhere around the 2.7 version, the 2 at the last number out there being the most relevant, it's the big number. The smaller versions then are off to the right. There is a version 3.7.2 for the Macs. Well, that's the version we need in whether we're doing a Mac or we're doing a Windows version, is we are doing some version of 3.something code. There is a big split. There's a difference in how things work. And if I look at documentation, you'll see that there's a lot of code differences between 2.7 and 3.7. So notice I clicked over here onto documentation, and it's actually got this page split and says here are 2.x resources, so 2.anything, and this is 3. You'll see that if I go to their tutorials, there are some very great helpful tutorials. This, however, is version 2.7, and there are a lot of differences in how the coding standards work. We are going to work on the 3. version. So I will caution you, if you decide to go out on the internet and you're searching for programming code, be aware that some of the code you're going to find is written in 2.7. There is so much legacy code that it still exists. It would be impossible to just arbitrarily say, all right, we're going to move to 3.7 and rewrite all of these programs very, very quickly. So this is a great resource over here on python.org. So I went to documentation, and notice there is everything from a beginner's guide, the differences in Python 2 or 3. So 2 is legacy, 3 is what's happening. So it has been since about 2008, 2009, 2010 when this changed. But this lists some of the differences and some of the things that you're going to have to deal with if you decide to write in 2.7. That said, are you likely to run into code that is 2.7? Yes. And in fact, if you have a Mac, one of the interesting things you can do is go to your terminal shell, and if you type in the phrase Python, it pops up a Python editor. And even on the latest version of Mac OS X, some of that is still in 2.7. It's still out there, but we're going to go to the version 3. So there is a discussion board assignment relating to that over here. So we're transitioning to Python. So I'm telling you to install version 3.7. But the book talks about 3.1.0. So immediately after this book was printed, it was already out of date. So I want you to examine what kind of issues you might have. And so this site is a great place to begin that research. So we're beginners, so we can go to a beginner guide right here. Now, the beginner's guide has a lot of information, and in fact it links to a complete list of guide pages. Those might be a great thing to look at as we start this. In fact, there's quizzes, there's packages in here, all kinds of information. Whether we go to 2.1, Python Facts. So there is all different kinds of things, all the way up to advanced. There's search tools. There is even a tutorial. And that tutorial will take you step by step by step. So when you get stuck, and if you get stuck, this is a great way to look at this. But some of this isn't as easy to read as a textbook, which is why we actually require you to buy a $20 textbook. There is far more information on this website than we will ever get to in a single class or a single program. But you have to be willing to look for it, and you have to be able to interpret it. If I go online, though, and I just look up Python tutorials, you'll see that there are videos, there are links. So this one is actually within python.org. There's all different kinds of ones. There's one even at that W3 Schools, which is where a lot of you have spent time if you've been in the web design class. W3 Schools, because Python is so tied into our ability to connect to the web, so they have examples. And they even have some interesting ones where they have some interactive tutorials, which are handy and useful when you start working through there. So there are a lot of resources. You have to be willing to utilize them and to try things. One of the things that you will not do anytime in here is break your computer. You cannot break your computer running Python. It won't happen. Don't be afraid to try things in Python. So I'm going to go through this install one more time really quickly. So I go to python.org, the main site. I am going to go to downloads, and luckily for me, it's right here actually. But I can also click here and go to Windows, and I can pick a package that I would like to install. So if I decided, you know what, I really liked, there's a change that I don't like, and I want to find 3.6.7, there is a method to do that, and so I ran it. I can install it, upgrade it. So in this case, we're going to upgrade. These should not take long to download. If you come up and says, you have an hour to download, we really need to talk about your internet speed or there is some other issue on your computer. The one issue I have had running into this, installing it, has been with antivirus software. So the one that we have seen an issue with is WebRoot, but I will not say that it won't happen with any other ones. You may need to temporarily disable your antivirus program to install, and that is possible with any program you install. So we're installing this version, and it doesn't take long, and I almost always go through the defaults. For what we're doing in this class, the default will work on almost anything. So make sure you are downloading, quite frankly, any of the 3-dot versions. If you're on their main page, it's just as easy to grab the latest version of either Windows or the Macintosh version. So in my office, I just downloaded and installed this on OS X to see what it's going to look like. It looks very, very similar. So the 3.7 I do have on a couple of different platforms. If you really are curious, you can look at other platforms, and it is available for nearly everything that you can run into. So you can probably find it for your tablets if you want to do that, even on some form of a tablet. Again, it will look slightly different. All right, so I'm going to close. So now I have Python installed. It doesn't pop up and say anything flashy. And here's the one weird thing. So if I hit my Windows button, which of course pops up in the other window, but if I click my Windows button and I type Python, I don't really get anything that looks like what we want to go to. What I need is something called idle, I-D-L-E. And this is what we're going to use almost everything in, is this shell that you're going to see here. That's Python right there. But we are going to do a couple of things to make life easier. This first shell that pops up is an interactive model where if I type a command like print, and because it is a function, and we know that all functions go in parentheses, I have to put in the content that I want to print into those parentheses. And if I hit enter, now it handily printed out 1, 2, 3 or whatever number I put in there. If I did the same thing, and I put that in quotes, or I put something in quotes, notice it color codes it a little differently. So anything that's inside quote marks generally is green, and that means it's a string. It's going to print that out the most common thing I see as we go through this class is not ending your comments, not ending your quote marks, not ending your parentheses, not having a colon or a semicolon. So you have to make sure what's at the end of my lines is correct. Because if you don't, it doesn't know where to stop. These computers are really, really, really dumb. They only know exactly what we tell them to do. In this case, we said you're going to print out something that's inside of this set of quote marks. If I did it this way, but I forgot that quote mark, it actually says end of line. Well, I don't know what this, and a literal is a string in Python. And it says I don't know how to deal with this because it doesn't end. I don't have an end point. What is text? What is not text? And so it's going to break. Anytime I see red in here, that means there's usually some kind of a syntax error. So syntax relates to our structure, not anything else. So I'm going to close this. I get it back by hitting the Windows key and typing IDLE for that Python idle environment. On a Mac, you can set it up to launch out of the launcher if you want. You can find it under Applications. So this tells us a little bit at the very beginning that it says it's version 3.7.2. It's a 32-bit version. You can run the 64-bit versions. For what we are doing, we do not need any more memory space, and there is no advantage to running the 64-bit version versus the 32. Our programs aren't going to be that large, but if we did have a giant program, we might need to run it in a 64-bit environment to be able to build that. Well, this program we're going to work with, a lot of software is actually built in. So it does a couple of things. It's a great scripting language. We can run things very quickly. It also can build an entire program that you might use. So we will look at some of those as we go through here. So this is that shell, that interactive mode. Well, that's not as useful to us as the ability to run in batch mode or the ability to create a file that we can use. And it's really tough. Everybody with me? If we move up to the top of this and you click File and you click New, does that look different? So the model we just opened when we clicked File New looks different. So this is a model that we can actually use to build multiple lines of code by using File New. This model over here, I can run one line really quickly. It's great for testing out something. Over here, though, I now have the ability to, we figured out we can do a print statement. And I can put multiple lines in. And you can write as many lines as you want to in here. So this is an editor that we can use, and we can write multiple line programs. And in fact, up at the top, it's got a Run button. And so if I click the Run button, it says, oh, do you want to run this module? Yep, I do. And before I can do anything, it requires me to save this file. If I just click OK, it brings up a dialog box and says, where do you want to save it? Well, right now, if I saved it in this app data on programs, you're not going to be able to find it very easily. This is where if you're in the computer lab, you probably need to bring a flash drive to be able to store your documents. So you have somewhere that you can store them. At home, you should probably pick a folder, maybe put one in Documents, somewhere where you're going to store them. Somewhere you know that you are going to store these files. All of our files end in .py, that file extension. That .py just tells the computer that it is a Python file. The reality is it is actually just a text file. And in fact, I can open up one. Open with Notepad. So here's one I opened up just with Notepad. It is a simple text file. Any text editor we can actually use to create them. Notepad doesn't give us, though, that color coordination. So I don't have the, come back here. When I do this, notice how it color codes everything. Notepad doesn't give us that. But I can open a Python file with any text editor. It's just a simple text file. So here we're going to save it, and I need to find a place to do that. So I'm going to create Documents. And I'm going to make a new folder in here, CMIS 210 Python files. And now I can save that as my class sample. So, one thing that we are very guilty of doing that Python does not like is putting in spaces in those file names. Just like in your web design class, for a lot of you who've had web design already, you can't use spaces in file names. It creates issues. File names can create issues in Python also. The reason is that computer, it's really dumb. It reads this name, class, and if I don't have anything except a space, it thinks, oh, you're done with that file name. But I might not be. So you can use the underscore. You can use what we call that camel case that we've used before. Just don't leave blank spaces in there. You want a descriptive name, one that you can remember. So class sample week 1. And when I click save, it automatically saves that as a Python file for me. And then because what I was actually doing was running it, then that program runs over here on the left-hand side of my screen. If I go to Documents and I go to, notice it even has a funny little symbol, and it says that it's hiding in there. It tells me a little bit about it. I could then open it in any kind of manner and I can edit it. But I have to file save this every time. Any change I make, so if I added a couple more lines, it's not going to run. So F5 is my short key to run a program. It's not going to run until it saves. So one of the problems we run into is you keep saving and saving and saving, and you made an error somewhere in there. You might want to do some versioning as you go through here. Before you make big changes, come up and do the save. Go File, Save As, and perhaps put it as a different name so that you know where you're at. So this might be try 1. And that way you don't lose documents that you have or data that you have. So That's the trickiest part, making sure that you save those. When you turn these into Blackboard, Blackboard doesn't care that you're turning in a .py file. But there's a couple of things I need you to always do. And that is, I need in comments, I need your name and the assignment number. Because I'm going to grab all these. I won't know whose assignment it is unless you have a name on it. So we have done comments in pseudocode. How do we do comments in Python? So we used slashes to indicate a comment tag in pseudocode. This is a difference between this language and other ones. They all have slightly different that syntax. So if I do a hash code or a pound symbol, notice it turns red. Yeah. It's also a really great tool when we're doing testing on your code. So you need to have a comment tag with your name in it and the assignment so we know what they are. And the use of those is free. They don't cost you anything to use these. You can put them at the end of text. So this program will still run even though it's at the end of text. You can put them in an entire line. The other thing you can do is if I need to troubleshoot and I want to see what happens if a line of code isn't there, when I put that in front of my line of text, automatically it turns it all into a comment tag. So my print statement now is changed, and it actually, if you look at what it's doing here, it changed what we have for output. So those comment tags are free. You need to use them and use them liberally. Sprinkle them like salt. But anytime we do anything, you can put a comment tag above it so you can understand and remember what you were doing. Below, I am printing 3 lines or 4 lines. And you think, well, why do I need all this stuff in here? So when I go through and I read it and I'm trying to figure out what you've done, it helps me understand where your thought process was. It also helps you go back and figure out what you have done. You can use it to block out comment and code and all different kinds of things inside of there to make life a little easier for you. So comments are one of the greatest tools we have. Use them. Use them. In 1967, when we had to hard code everything and we didn't have much storage space, we didn't put a lot of comments in. Today we can put them in. It can make your life a lot easier. You go back after you've taken a couple hour break and you go, what was I trying to do here? Oh yeah, let me look at my comments, and this is where I was at and what I was doing. So this is where we're going to spend the next 8 to 9 weeks, is inside of this Python environment. So your assignment this week, so you actually aren't coding in Python yet. We're going to practice, we're going to play and show you a lot of places to go do that. But right now, we're doing a couple of things. So you have to answer some questions. How do we do comments? What are they used for? So there is an assignment this week. So there is a discussion board and an assignment, both of them related to how we use and interact with Python. The book that you are using, the Python book, you really need to read chapter 1. It is short. You need to have Python installed in an environment that you can utilize. And again, it will run on almost anything. It is not a very large file to install. So there is a quiz that will pop up. You can get this on almost any device that you could possibly run into. So the other piece we need to deal with is we need to finish up chapter 7 out of our textbook, the first one we looked at. And I'm going to shortcut this a little bit. I left the entire slideshow up there, but I want to deal with a couple of items in here. So Python is what we call an object-oriented language. So we try to create objects, so we don't have the idea of those minutiae, that detail. So just like we did those modules, where now you can concentrate on that main line, the big picture. That's very similar to what we're doing with our idea of modules or object-oriented programming. Essentially, you're creating, I always like the term black boxes. You're creating a box that you're going to send data into, and it's going to manipulate it and bring it back to you, and you don't have to deal with those details at that particular point. So there are some terms you need to have, and we need to go over. So, class. Class is how we distribute and break up items. So they often have not only the ability to store data, but they also will have actions. And so the best example I really use is at a business, we have a people class. That people class, everybody is very similar. We all have very similar characteristics, so we can be a group called a class of people. We all have a birth date. We all have a social security number. We all have all these very similar characteristics. So, an object then is one example of that. So, in the class people, I am an object or an instance of a person. So I know that seems a little odd, but take a look at this. This maybe makes more sense. So if we have a dog, we know that a dog has certain characteristics. They have a name, they have an age, they have a shot status. They also have things they do. And notice we call those a lot of times methods. So they have an eating method, a running method. If you wanted to include other things, what other things do dogs do? Maybe a sleeping method? A pooping method? Yep, they certainly do that. So those are all things. And notice, we can tell they're a method, even if we didn't have the term method right in there. How would we tell they're a method? How would I tell from that picture that that is a method? That running method is an action. What's at the end of running method? Those parentheses. So just like when we created those modules last week, that parenthesis says, hey, this is a function. It does something. So over here, on the right-hand side, we actually created a couple of those instances. And they each have individual data. So that class, they get their data from that, or the data holding spots from that, and then they each have their own independent characteristics. So think about a video game. Most of you have played some form of a video game. When I create, remember the original Space Invaders? And you have all the little marching aliens at the top. Each one of those aliens is an example of an object. They each have their own independent characteristics. And I can create them, though, based on the idea that I can inherit some of these items down. So, when we create an object, we create an instance of it. So that defining a class really only has a couple of things. It says, has a name. We know we have to call it a name. So, class dog. Most classes have data. Not required, but they also, or they will generally either have a data or a method. There are times when we only have methods. In other words, there's only actions associated with it. So, every data piece we have creates some kind of a field. So think about it in terms of a database. It's creating a field where we store data. And then we also have that idea of we have an action or a method. So here we are defining something called a class employee. So up at the top, we simply say, hey, we're going to create a class called employee. Inside of that employee, we have a couple of fields, and they have a name and they have a pay rate. Well, those are important. And then we have a set of methods, and those methods should look very, very similar to what you created earlier. That void simply says they're not going to return any value. They're going to do something, but they don't return a value. So, the first thing we do is at void, we have a method called setName, and it has a string and a variable called lastName. So we send into this method something called lastName, and it creates a variable called name. So we're just creating a way that we can name our individual object. Set pay rate, well, that one's pretty important. We like to have our pay rate set. So we have a method that sets that pay rate equal to a value that gets pushed into it. We have one called getName. We have one called getPayRate. So some way we can get that data back out of a particular employee. So we have a way to put data in. We have a way to put data out. So a couple things to remember. Just by making a declaration, that doesn't mean we actually created anything. We created that class over here called employee. That doesn't mean we've automatically hired an employee. We don't know if we even have any or not. We created a class, but we have not put anything in there yet. Until we create that object, we don't actually have an instance of it. When I do declare that employee, they now have the ability that that object can access any and all of those data fields and methods. So when I create it, it automatically gets all of those items. So just like our puppy back here, we said we're going to create an instance of a puppy. All of those things that are in there, name, age, shot status, all of those things are available to us to use as soon as we create one. So here's an example then of we're creating this user. So notice we have used those things. So we have a start and a stop. So we've got a program. And it declares a variable called employee. And we actually run that then. So it says my assistant dot. So you're going to see us use that dot notation quite a bit. That dot notation says we're going to run something called my assistant dot set name. So dot set name, notice there's a method in there. So we created an example of an employee called my assistant, and we can access it with what's called dotted notation. So I know that's a little strange, and we're going to get there. So, a couple of things when you start looking through your quiz. You need to understand public and private access. So we can specify whether that other programs or other methods can utilize those, or whether they're private. So if I set something like a Social Security number, that's private. I don't want other places to be able to manipulate that. On the other hand, if I set your status as a student and your GPA, I would probably want my PSC and when we enter grades to be able to modify that. So we can declare, we can say, hey, this portion is public. So the set name is public. The set pay rate is public. Get name is public, or get pay rate's public. But private is that string name and the pay rate up there where we're creating. So we can have public and private accesses in both. So there's some examples as you look through your book. So this is where we're headed towards as we get into Python. We're not going to get there for a little bit, but I want you to understand some of those concepts and those ideas that we're going to talk about. The other interesting take on this is this idea of something called inheritance. If my dad is Bill Gates, I hope to inherit something from him, right? But we all inherited things from our parents already. Your looks, your appearance, your height, your eye color, your hair color or lack of hair. You guys all got things that you inherited from your parents, right? Well, this is the same way we're going to do with a class, is I can inherit items from a particular another group. So here we're saying I'm going to take the class salesperson and I'm going to inherit all the items of employee. All the employees have similar characteristics, but salespeople might have some differences in how they get paid. And so we're going to deal with that a little bit. So if you think about it, at Peru State College, do we have an entire group called people? Do we have subsets of that they could inherit? So are there students? There's faculty, there's staff, there's volunteers. Those could all inherit from that people class certain items. So that base class we also call a parent class. Just like you get stuff from your parents, we're inheriting from them. So usually the term I hear is child. They might be derived. It's kind of sad to call them a subclass, but usually we call them parent and child. And so sometimes you even have multiple layers. Multiple layers. So here we might have people as a class, and we might have students as a class, and we might have employees as a class. Then under employees, we might have faculty, we might have staff, we might have volunteers, however we do it. So we can often be more than one layer deep. But it's that idea of inheritance. Whatever the parent has, you're going to end up with. So for those of you guys who look at your dad and he's bald, good luck. You're probably going to be a little short on hair. So the same way we inherit items, we inherit this idea. So we're throwing out a ton of terms in here. A ton of terms. But we're trying to get you ready for this jump into Python. So polymorphism. That's a big word. And all it really means is we write our code so no matter what kind of data you put into it, it works correctly. So if I have a module and I put in a piece of text or I put in a number, it's going to handle it and deal with it. That's really what we're saying. So polymorphism really means that we have multiple methods and we can deal with any kind of data that we have in there. So the other big term we need in here is something called encapsulation. So most of us is tomorrow, sometime late tonight, you're going to encapsulate in your blankets. You're going to wrap yourselves around them. So all that really means is we're going to wrap up all of these items and it lets us make things portable. So why do we do this? This sounds horrible, doesn't it? We have all these methods and classes and polymorphism and encapsulation. Well, we want to do it for a couple of reasons. So we want our programs to be safe with data. So we have to write them so if you have personal data in there, I don't want everybody to be able to see my data when they log into my PSC. It'd be easier to write it if you could log in and go, oh yeah, today I'm Jim and I'm going to look at somebody else's records. But we want to be able to keep them all separate. It also lets us reuse things. So just like those little modules, now we're going to reuse things on a little bigger scale. I already know all those attributes about people, and I have all these employees I need to program into my system. Why not use that? And so it makes stuff a little easier to reuse or manipulate. We are creating this idea of these boxes that we can just shove into place and modify. This polymorphism says, well, you know what? Because my program is written very cleverly, I don't care what kind of data you send to me, it's going to work correctly. We have to remember we can inherit from one object to another. So there is a lot of these things that already exist. We don't need to reinvent the wheel. We can make life easier because we can do that idea of inheritance. So I went through really quickly this book piece about object-oriented programming. It really just means we're creating things in boxes and we have this idea of classes. It's nothing you haven't done before. We're just rewriting how you think about it a little bit. When you see a person, you already know they have certain characteristics. That's a class of person. When you look at a dog, you know they have certain characteristics. When you look at a building, you know that a building has certain characteristics. A building could be a class. So what would be a method that a building could have? What does a building do? What are we grateful for in this room, even though it's not very warm, does this building do? Heating. That's a method. So we could create a class of building if we wanted to create something. So we could, instead of our print hello, we could create a class building. And that building's going to have certain characteristics. What's common to all buildings? If we're going to build something about a building, what do we know about them? What do all buildings have? How do we get into one? Doors. All right. What other things do they have? Walls. I hope they have a roof. So I bet a building has a name. It's probably got an address. So those are all characteristics of a building. Are there more we could put in there? Yeah. But for now, I'm going to go down and we're going to look at a method. So we know that it's got a heat method, we hope. Are there other things a building can do? So we're just writing this kind of an abstract class about a building. So that's our entire class. But do we have an object yet? We've written a class, but we don't have an object yet until we instantiate that object. So in other words, we create an object and give it those characteristics. It can inherit all of those and store all of those. So if I want to declare one, so now we can declare we have an object of TJ Majors. And so it's got doors. How many doors does this building have? Let's say 132. I've never counted them. So it's got 132 doors. It's got, let's say, 41 walls. It has a roof. Yes. Yes, it's got electricity. TJ Majors is its name. Its address is... And we know it's got a couple of methods. So we have built this module now. Now we have an instance of it, or an object. Oh my goodness, you okay? We have a building. It's an object. We created it. Do we have more than one building on our campus? Yeah. So we could create these for every one of our buildings on campus. So you're creating an object for each one of them. Now it seems silly when we do this with a building, but I just want to point out we do that, and we do that in our programming language. So is there a governmental agency that does things like this? Oh. What's the name of that office that does that in our county? Do buildings pay? Do you have to pay taxes on buildings? Let me rephrase that. So in the assessor's office, they are doing something like this. In the background, they are building classes for each piece of property. Each piece of property has certain characteristics, and they build your tax statements based on those characteristics. So if I'm the assessor and I have a class building, maybe I don't have that module for heat and cool. Maybe I have one for tax. So we have a module, we have a building. Now we can create examples of that building. So just like in a video game, each example of that character you play is an object, the same way in we're doing here. So we have a list of objects. So once we built this, we could have a whole list of objects. So we would have TJ Majors. We would have the AWAC, Gendra, library, cats, whatever other buildings are in there. The complex, Delzell, Morgan. Those are all now objects that we created once we built our system, and we initiated those objects and added content to them. we can create objects that don't have any of these. So even though we have a field for doors, walls, roof, electricity, that doesn't mean we have to do it right away. We might have created all those objects and they don't have any values in there yet. We just created the name of that object. So I know this sounds confusing now, but it really makes life easier later on when we're starting to write things. For example, when you want to play a card game. If I think about a card as an object with this amount of characteristics, it makes life easier for me to then build a card deck and simulate, for example, a card game of some sort. So this is the hard thing to wrap your head around. It's easier once we do it, but I want you to have an idea of where we're headed to, this idea of classes and objects. And this is where almost all programming is headed, is this idea of object-oriented programming. Once one group of programmers creates things like our classes, then we can utilize them throughout the entire program. So it also makes that idea of groups of programmers makes their lives easier. So something like the Mac OS X. One person doesn't write that, or Windows, right? We know that it's got to be a team of programmers to write a large system. These are some of the things we do to make that easier for you and easier for them, is things like these idea of classes and objects that we create inside of it. Well, that is our tools we have to make life a little easier for us. All right, on Thursday, after our last snowstorm again, we're going to go back over this another time on object. We're going to look at Python again, look at some tutorials. So make sure you have read the book. So you're in the Python for Beginners book, Chapter 1 and Chapter 7 of our text. I am rewriting the quiz to be a little easier to make life a little better, since we're not going to go into quite as much detail. We're going to move into Python a little quicker. So the quiz will be a little different. It should pop up sometime this afternoon, depending on what time we get done with all of our meetings. So today our new chancellor is on campus, so we're going to have some meetings and town halls and things. So if you've gotten some emails about that, that's what's going on. Try to go to some of those. Put out your input, your output. What do you think about Peru? So this is a new person in a new position this year. How do we stand out from our other state colleges? How do we make ourselves stand out for the scarce resources that are available at the university system? So it is important to go out and voice your opinion. All right, any questions? Anybody want to have a guess on how much snow we're actually going to get?
4 inches.
4 inches, 1 inch. Now I see something about 6 to 10. I think the weather forecasters like to keep drumming this up because it keeps them on the air. I'm going to invest 3 to 4 inches is all we're going to get out of this. So. And I am also predicting we will not have a snow day tomorrow. You guys all look sad when I said that. That's good. You get to come to class and enjoy and learn. Oh, a late start. We'll have to see. If the weather does get bad, everybody be careful. Unless you're on campus, and then there's lots of nice sledding hills in town. Don't run into a tree at the end of the sledding hill, though. That's my only advice. It does until you're frozen. All right. Anything else? Questions? Comments? We will also briefly go over our homework for last week on Thursday. I had to think what day it was. All right. Let's get out of here, stay warm, and enjoy your not having a snow day tomorrow.